Hello everyone. My topic of the project is the OFDM simulation in a multipath fading channel. And the main objective of this project is to study and simulate how OFDM systems behave in multipath fading channel. And in the wireless telecommunications, multipath is the propagation phenomenon that results in radio signals reaching the receiving antenna by two or more passes. And in multipath fading channel, the signals through different passes will have different delays respectively. And those delays at high channel sampling rates would be resolved by communication system and it cost ISI. And we can see here, this figure illustrates the ISI or inter-sample interference. The delayed version of the previous symbol overlap the interface with their successors, which cause the ISI or sample interference. And in this case, the delay spread of the channel is larger than the symbol period of the signal, which results in the frequency selective fading channel. And this is the frequency response of a frequency selective fading channel with magnitude over the signal bandwidth. And basically, there are two solutions to handle ISI issue. One is equalization, and the other is OFDM, which is the main topic of this project. Both FDM and OFDM divide the total available bandwidth in spectrum into subbands for multiple carriers to transmit in parallel. Thus, a long symbol period can be achieved and for the same throughput of the system, and ISI can be avoided because the frequency selective fading are reduced into flat fading. And for basic FDM, the guide bands are needed to prevent the bandwidth of subcarriers from overlapping. And in the OFDM case, two subcarriers are orthogonal to each other. Therefore, the intercarrier guide bands are not required, and a high spectrum efficiency can be achieved. And another reason to implement OFDM against ISI is that the cyclic prefix is added in front of each OFDM symbol period in time domain. If the prefix is long enough, the delayed version of the previous symbol cannot affect the useful data behind the prefix. And in this way, the ISI can be avoided and handled. And this figure shows the interrelationship between the frequency domain and the time domain of the OFDM system. And in the frequency domain, multiple adjacent subcarriers are independently modulated with complex data. And an inverse FFT transform is performed on the frequency domain subcarriers to produce the periodic OFDM symbol in the time domain. And then in the time domain, cyclic prefixes are inserted between each of the symbol periods to prevent the ISI that caused by the multipath delay spread in the radio channel. And at the receiver side, an FFT is performed on the OFDM symbol to recover the original data. And this is the bar diagram for my OFDM simulation. And the source data here is for this simulation is taken from an 8-bit bitmap image file. This image data will be convolutionally encoded and then be converted to the symbol size determined by the choice of modulation, like PPSK, QPSK, and setting PSK and setting QAM. And the converted data would then be separated into multiple frames of OFDM transmitter, and the OFDM modulator modulates the data frame by frame. Before the reset of the transmitter, the modulated frames of time signal are cascaded together along with frame guards inserted in between, as well as a pair of identical handler and trailer added to the beginning and the end of the data stream. This communication channel is modulated by rarely fading and Gaussian white noise and amplitude capping effect. And this is my OFDM simulation parameters. The parameters we can see here. The FFT size is 128. The number of carriers is 48. Modulation method is setting QAM, and peak power clipping is 6 dB. Max Doppler shift is 0 Hz, and with channel coding, and the SNI is 12 dB. This is the original figure of the BMP file, and this is the simulation data for simulation results for transmitting data before the IFFT transformation. And because in this job project, only the real value time signal are treated. In order to generate the real valued time signal, OFDM carriers must be defined in complex conjugate pairs. And the figure on the left is the OFDM carriers on the IFFT beams, and on the right is the phases of OFDM modulated data. And this is the received data for the OFDM receiver. The figure on the left is the magnitude of received OFDM spectrum, and the figure on the right is the phases of the received OFDM spectrum. And this is the figure on the left is the time signal for one symbol period in one carrier, and the figure on the right is the consolidated data for the OFDM receiver. And this is the figure on the right is the received image file from the OFDM receiver, and the bit rate BEI is about 80%. And this is the OFDM simulation. The figure on the left shows the influence of channel coding in the OFDM system. The blue one is with channel coding, and the red one is without channel coding for CTQAM. And the figure on the right is the shows the BER performance for different modulations. And now I will show you my program. So OFDM sim. So actually this one is for PSK, and first we choose the source file, and then is the FFT size, number of carriers, and the modulation. We choose the 16 PSK, and for this one, for this clipping value, we choose the 6, and radiation we choose 16. Okay, you can see these figures. It will take some time. And the output data is, this is the output file, this is the input file. We can compare with each other. Okay, I think that's all. Thanks for watching.